Welcome back students. In this video we will discuss UV method in details. So let's join the lecture. Welcome students. In this video we are going to discuss MODI method or UV method. Before discussing it, first we will discuss about the scenario of transportation problem. Transportation problem has two phases. The first phase is finding the initial basic feasible solution in the first phase, and the second phase is optimization of that initial basic feasible solution. The first step is finding the initial basic feasible solution and the second step is optimization. Furthermore, the initial basic solution has three methods to obtain the basic solution. The first step is northwest corner method, the second one is least cell method, and the third one is Vogel approximation method, which is VAM method. You can find the initial basic feasible solution by any of these methods. I already uploaded videos on thrice, so you can check it out. The second phase is optimization of feasible solution. The solution can be optimized by using UV method. For this problem, we have to solve the problem in two phases. First, we have to find the initial basic feasible solution, then we have to optimize it. So here is the problem, in which there are four destinations 1, 2, 3, 4 and 3 sources 1, 2, 3. 4 destinations and 3 sources. Supply is here and demand is here. First we have to check whether the problem is balanced or unbalanced. Students, as we have discussed earlier, the sum of supply when becomes equal to sum of demand, the problem is balanced, otherwise unbalanced. So we have to check it out. 300 plus 200, 500 plus 50, 50, 600. 600 plus 400, 1000. 200 plus 300, 500. 500 plus 300, 850, and plus 150, 1000. So we get it out, the problem is balanced. So we don't have to put any dummy row or dummy column. We have to solve this problem by northwest corner method. We will solve this problem by using northwest corner method. So in northwest corner method, we have already discussed, we have to choose the value which is more west and more north in the whole column. Just see the directions. We have to choose the number which is more on the west side. We have to choose the number which is more on the west side and more on the north side. So 3 is the respective number because 3 is more the west side and more the north side. With respect to 3, there are supply and demand. We have to choose the least value in supply and demand and allocate there. 200 is the least value, so we will write 200 here. So 200 will become 0 and here will remain 50. Okay, when any demand becomes 0, the whole column will become 0. At the same time, when any supply becomes 0, the whole row becomes 0. So this row will be cancelled. Now we will move further. Now we have 3 rows and 3 columns. We have to choose the next number which is more on the west side and more on the north side. 1 is the respective number. With respect to 1, 50 is supply and 300 is demand. We will write 50 here because 50 is least and 300 is more. So here will remain 0 and here will remain 250. The 0 will cause the cancellation of whole row. Now we will move to the next number. 6 is the respective one because 6 is the more on the west side and more on the north side. With respect to 6, supply is 350 and demand is 250. We will write 250 here because 250 is less and 350 is more. 250 will become 0 and 350 will become 100. Here we get 0 number, so this column will be cancelled out. Now we will move to the next one. The 5 is the respective number because 5 is more on the west side and more on the north side. With respect to 5, supply is 100 and demand is 350. We will write here 100 because 100 is least and 350 is more. We will cut down 100. Here will remain 0 and here will remain 250. Due to this 0, this row will be cancelled out. Now moving to the next number. 3 is the respective number. Supply is 400 and demand is 250. We will write here 250 because 250 is least and 400 is more. 250 will turn into 0 and 450 will turn into 150. 250 is turned into 0, so this column will be cancelled out. There is one element is remaining. Students, when the supply and demand at the last cell becomes equal, this means the question is doing right. So we will write 150 here. 150 turns into 0, 150 turns into 0 and the whole column will be 0. So we will write now the allocations to find the feasible solution. We are finding the initial basic feasible solution. We have put northwest corner method to find the initial basic feasible solution. Now we will find the solution. 1 into 50 plus 200 into 6 plus 100 into 5 plus 3 into 250 plus 2 into 150. So here we will solve this. Students, we have done the first phase. Now we have to find the optimization of basic initial feasible solution. First we will define the terms ui and vj. In UV method, ui are the u1, u2 and u3. At the same time, vj is the v1, v2, v3 and v4. The sum of u and v is the Cij. Cij is the allocated cell. There are 6 allocation: 200 into 3, 50 into 1, 6 into 250, 5 into 100, 3 into 250 and 2 into 150. There are totally 6 allocations. First we will find the number of allocations. Number of allocations are 6. By finding this formula, we will find by using this formula m plus n minus 1. M is the rows, n is the columns and minus 1. There are 3 rows, 4 columns, minus 1. 3 plus 4, 7. We will find it by De Moivre's rule, division, multiplication, addition and subtractions. Division, multiplication, addition and subtraction. Addition come before subtraction. So we will add first 3 plus 4 7, 7 minus 1 6, 6 equals to 6. It means it is right. Now we will find the value of v1 v2 v3 v4 and u1 u2 u3. The first value we have to suppose 0. u1 Cij C11 is 3, so we have to suppose the value v1 3 because u plus v equals to 3, so 0 plus 3 equals to 3. Let me repeat, we have to find the values of u and v by the value of Cij C11. This is C11, this is C12, this is C13, this is C14, this is C21, C22, C23, C24, C31, C32, C33, C34. C11 is 3. U plus V equals to 3. 0 plus 3 equals to 3. I hope you are getting. The second allocation cell is, for second allocation cell, Cij is 1. So 0 plus 1 equals to 1. So V2 is 1. So V2 equals to 1, students. 0 plus 3 equals to 3. 0 plus 1 equals to 1. Moving towards the third allocation cell, the number is 6. So here is 1. 1 plus 5 equals to 6. We have to find the numbers by using the allocated cell number. Here is 6. 5 plus 1 equals to 6. Moving toward next one, 5. u2 is 5, then uv should be 0. Okay, now moving toward the next one, the cell number is 3. v3 is 0, so u3 should be 3. Now v4, the number is 2 and u3 is 3. Now what will we do? u3 is greater than the cell, we will give the value in negative. We have given the value -1 because 3 minus 1 equals to 2. Students, I am repeating, we have to find the values of u1 and v1 with respect to C11. Same, we have to find the value of C12. We have to find the value of v2 and u2 with respect to C12. We have find all the values. Let me check. 0 plus 3 equals to 3. 0 plus 1 equals to 1. 5 plus 1 equals to 6. 5 plus 0 equals to 5. 3 plus 0 equals to 3. 3 minus 1 equals to 2. So we have done this equation for allocation cells. Now we have to chase the second equation for the unallocated cells. This was the first step of UV method. Now we will do next step. Okay, we have to chase this formula. First we have find the values of u and v by the allocated cell. Now we have to find this equation Pij by non-allocated cells. So by using this formula, C13, which is row 1, C13 which is row 1 and column 3, and C14 row 1 and column 4, C21 row 2 and column 1. At the same time, row 2 and column 4. We have to find the 6 values here. So in C13, the value of v and u is 0 and v is and V is 0 and Cij is 1. So 0 plus 0 minus 7 equals to minus 7. We will find all the values. In the same case, the video will become so longer. Okay students, now we will move to the next equation or next step. We will find all the penalties here by the formula U plus Vj minus Cij, the allocated cell number. For C13, here U is 0 and V is 0 and the cell number is 7. So 0 plus 0 minus 7. So for C14, U is 0 and V is minus 1. 0 plus minus 1 minus 4. In the same way, we will do all the sums. After finding all the sums here is positive 6 and here is positive 1. The rule is all the numbers should be negative or 0. We will choose most positive number, which is 6, and then we will choose that allocated cell. The respective cell is 2. Now for this, we will make a track closed loop which travel from allocated cell to allocated cell. We will move here. We can further move here, but by moving here we cannot move furthermore because this is unallocated cell. We can move below, but same we cannot move here left or right. We need a closed loop for the next procedure. So we will travel here and then here and then here. We make a closed loop there. The first sign, the respective number will be positive, the next will be negative, the next will be positive, and the next will be negative. The value we call it x. We will chase both negative values 250 and 200. We will choose the least number, which is 200. We will add or subtract 200 according to the given condition. We will add 200 here, subtract 200 here, plus 200 here, and subtract 200 here. For this purpose, we have to make a new graph to proceed furthermore. We have created another table. In this table, we will write the allocations according to the given conditions. There is no allocation, so plus 200 will become 200 allocation in that number. Here is 200 allocation already. The subtraction of 200 will cause 0. No allocation. Here is 50 allocation. Plus 200 will cause 250. 250 allocation. Here is 250. 250 minus 200 will cause 50 allocation. All the other cells will remain same. Now we will find again the penalties. For finding penalties, we have to find the values of u and v by the formula ui plus vj equals to cij. For this purpose, we will find again the values of u and v as we have discussed earlier. Here is 2. We will find the values of u and v with respect to 2. 5. The value of u is, we will suppose 5. 5 minus 3 equals to 2. The next allocated cell is 1. We have supposed 0. The first value we will suppose 0 to move further on. 0 plus 1 equals to 1. 5 plus 1 equals to 6. 5 plus 0 equals to 5. 3 plus 0 equals to 3. And 3 minus 1 equals to 2. Now we will find penalties with the help of unallocated cells. So here are all the penalties. This is negative sign. Here is number 9. I have written mistakenly 4 here. This is 9. So to make it positive into negative, we will again draw the whole sum and we will find cells, the values of u and v. We will find penalties same as we did earlier. For value 1, 3 is the respective number. We will take it positive, next negative, next positive, and next negative. We will move from here to here to here, and then we have a closed loop. We will nominate negative signs, which are the allocation of negative numbers are 250 and 50. 50 is the least number, so we will choose 50 and subtract and add 50 in all the numbers. We will subtract 50 here, plus 50 here, minus 50 here, and plus 50 here. So we have to draw another column for this purpose. So here we have drawn the other column. This was blank, so here will come 50. 50 minus 50, there is no allocation. 100 plus 50, 150, and 250 minus 50 becomes equal to 200. So here is the new column. No allocation, 150, 50, and 200. The other, all the cells will remain same. There is one positive sign. So by making this letter negative, we are doing this sum. We will find the values of u and v as we have find earlier. 0, we have to choose 0 for first allocation. For first allocated number, 0 plus 1 equals to 1. 4 minus 2 equals to 2. The next is 0 allocation. 2 plus 1 equals to 3. 4 plus 1 equals to 5. 2 plus 1 equals to 3. 2 plus 0 equals to 2. We have find all the values of u and v with respect to allocated cell by using this formula. By adding u and v, which it becomes equal to Cij, which is the C1, C11, C12, C13. That's all. Now we will find this equation from unallocated cells. Pij, we will find Pij for unallocated cell. Let's say number 3. The value of u is 0. The value of v is minus 2. The allocated cell number is 3. So by using these signs, we have to write here. Here is minus because the value is minus 2. Plus minus minus. So we will find all the penalties. 0 plus 1 minus 7 equal to minus 6. 0 plus 0 minus 4 equals to minus 4. 4 plus 1 minus 6 equals to minus 1. 4 plus 0 minus 9 equals to minus 5. 2 minus 2 minus 8 equals to minus 8. You can notice all the elements are in negative sign, so there is no need to further more allocation. This is the optimum solution. We can find optimum solution by multiplying 1 into 250 plus 2 into 200 plus 6 plus 5 into 150 plus 3 into 50 plus 3 into 200 plus 2 into 150. 250 multiply 1 plus 200 multiply 2 plus 150 multiply 5 plus 50 multiply 3 plus 200 multiply 3 plus 2 multiply by 150. We will calculate all this. By calculating, here is the result 2450. This is the optimum solution. If any single penalty will remain positive, you need to find the values of u and v. Then this equation and this alteration is required. When you obtain all the values negative, it means you have obtained the optimum solution. Student, this is the complex method of transportation problem. Let me repeat. First, we have discussed Modi method or UV method. Modi method or UV method is the second phase of transportation problem. The first phase is finding the initial basic feasible solution, and the second one is optimization of initial basic feasible solution, which is obtained in phase 2. The first phase involves three methods to find the initial basic feasible solution: northwest corner method, least cell method, and Vogel approximation method. The second phase involves optimization of feasible solution. UV method is used to optimize the feasible solution. First of all, we have a problem. This problem was balanced, so we do not need to have don't need to add any dummy row or column to balance it. This is already balanced. So first of all, we will find initial basic feasible solution. We find initial basic feasible solution by using northwest corner method. By using direction, we have find this sum, which is 3700. Now we will optimize the solution. The solution can be optimized by UV method. For UV method, we have to find the values of u and v, which equals to Cij allocated cell. So we have find the values of u and v. Then we have finded the penalties. The two numbers in this problem, two numbers are positive, +1 and +6. We have chased the most positive value here. Then we draw a closed loop, two side positive and two side negative. The allocation travel from allocated cell to allocated cell, and horizontal and vertical. We have find the least value, which is 200 in the negative ones. Then we added and subtracted 200 in the in all this. Then we find the penalties. Again, here is +1, so we have to negative this number also. So we will again repeat the procedure and then find the penalties. All the numbers will become negative by using this formula. Then the negative of all numbers means all the sum is absolutely right. Then we have find the optimum solution by using these allocated cells. Here is the concept of degeneracy. M stands for number of rows and N stands for number of columns, -1. There is a formula: when rows and sum of rows and columns -1 becomes equal to number of allocated cells. Students, there are 6 number of allocated cells, so we have written 6 here. There are 3 number of rows, 1, 2 and 3, and 4 columns, 1, 2, 3, 4. 3 plus 4 7 minus 1 6 equals to 6. This means there is no case of degeneracy at all. I hope you get this question. Thank you for watching. Do share and subscribe if you like the video.